To my co-presenters, listeners, and organizers of the Davao del Norte State College International Research Festival, a pleasant day to everyone. I am going to present the completed research study on predicting BSIT graduates' employability using Feedforward artificial neural network. I am Hazel A. Gameng, and with me in this study are Val P. Delos Reyes and Pamela Grace L. Denila. We are all faculty members of the Institute of Computing, Davao del Norte State College, New Visayas, Panabo City, Philippines. The outline of the presentation consists of the background and significance of the study, objectives, methodology, results and discussion, conclusion, and the recommendation. So every year, higher education institutions produce more graduates. The considerable number of graduates does not correspond to the number of employment openings. Graduate employment is currently a concern in several schools all throughout the world. In the Philippines, universities and colleges continually track graduates every year as a parameter of excellence by conducting annual tracer studies. So tracer studies are a means of maintaining curriculum relevance and providing targeted benefits to graduates to enhance the marketability of the educational programs. In data mining, artificial neural network is an implementation of the artificial intelligence technology that works like a human brain system that adapts the human nervous system so that it works like a human brain system that can process information, including training, remembering information, equating data, and determining patterns during the learning process. The artificial neural network is part of the advancement of data mining and is an effective and accurate tool in analyzing, modeling, and understanding data. The feed-forward neural network is popular and has been applied to a wide variety of problems, including function approximation, prediction, and simulation as arising from the variety of disciplines. So this study aims to classify the employment of the BSIT graduates of the NSC based on the students' grades in their core, professional, and elective courses using the traditional classifiers such as the logistic regression, naive-Bayes decision trees, and one neural network model, the feed-forward artificial neural network. And the second objective is to determine the performance metrics on the accuracy, precision, recall, and F1 score on each classifier. So the overall process involved in the study is shown in figure 1. It operated at various stages, namely the raw data, the preprocessing, and data splitting of the training set and the testing set. The raw data consisted of the BSIT graduates' grades in their core, professional, and elective courses, and their employability status classified as IT-related or non-IT related. So this included BSIT graduates from 2016 to 2020 who participated in the graduate tracer conducted by the Institute of Computing. For the data gathering, letters were secured before this was done, and representations of consent forms were also signed by the graduates, allowing the team to get their grades and employment information. For the percentage splitting, it used the 80% training and 20% testing data splitting. So apart from being a popular rule of thumb, the 80-20 rule is based on the Pareto principle, which states that 80% of effects arise from 20% of causes in most circumstances. The traditional classifiers logistic regression, naive-Bayes and decision trees were used, and the feed-forward artificial neural network was also used. For each classifier, the performance measures on the accuracy, precision, recall, and F1 scores are computed. Figure 2 shows the architecture of the feed-forward artificial neural model used in the study. So it consisted of 32 input layers and 5 hidden layers. The model was trained using the analysis data model optimizer with a binary cross entropy used as the loss function, since it is suitable for the binary classification problem. So to determine the best feed-forward artificial neural network model, it performed 50 iterations and applied an early stopping callback function. So testing and validation were conducted after training the feed-forward artificial neural network model to evaluate its performance. For the results and discussion, we have here table 1, which shows the summarized results for the performance metrics using the logistic regression, naive-Bayes, decision trees, and the feed-forward artificial neural network on the testing set. So each of the classifiers was trained using 80% of the data set and tested using 20% of the data set. So based on the results, it can be noted that the feed-forward artificial neural network led in all the metrics, showing that this more advanced classifier performed best for the employability data set used in the study. So the feed-forward artificial neural network exhibited the highest lead on accuracy over the decision trees by 14.28%, and the lowest lead on the precision metric on the naive-Bayes classifier by 4.14%. The feed-forward artificial neural network outperformed the other classifiers as it led on accuracy by 11.70%, precision by 6%, recall by 6.62%, and the F1 score by 7.54% compared with the combined average results for the three classifiers. An unseen dataset consisting of 20 records was created to further test the model. So the training and testing datasets do not include this unreported dataset. The findings of the performance metrics include utilizing the unseen data set are shown in table 2. So this demonstrates that the feed-forward artificial neural network outperforms other classifiers used, except that the naive-Bayes outperforms the feed-forward artificial network in terms of recall. The feed-forward artificial neural network exceeded the other classifiers by 20% in accuracy, 20.76% in precision, 11.67% in recall, and 16.53% in F1 score compared to the average results for each performance metrics for the three traditional classifiers for the unseen dataset. So to conclude, classification algorithms were used to identify what works well with the dataset of the employment of the DNSC BSIT graduates based on their grades in core, professional and elective courses, as well as their employment status, if it's IT related and non-IT related. So logistic regression, naive-Bayes decision trees, and feed-forward artificial neural networks were also used in this study. So each classifier's accuracy, precision, recall, and F1 score performance measures were calculated. In all measures, the feedforward artificial neural network performed best, followed by the naive Bayes and then the logistic regression. Among the classifiers utilized in this study, decision tree had the lowest performance metrics. As a result, it can be concluded that the feed-forward artificial neural network outperformed the other classifiers on the data set utilized in this study. For the recommendations to further improve this study, it is recommended to gather more records by strengthening the BSIT graduate tracer to increase the number of records in the dataset. And it is also recommended to use other artificial neural network models for comparison with the feed-forward artificial neural network model used in the study for the classification performance on the same dataset. That ends my presentation. Thank you very much and have a good day, everyone.